ranges, and what the definition of a function is. So as we start this discussion, I want us to think about a regular two-variable equation. How about y equals x squared? As we've already talked about, not every graph is a straight line. This one certainly is not because of the x squared. So let's take a look at the graph of what this thing looks like. If you think about ordered pairs that satisfy this equation, if x is 0, 0 squared is 0. So 0, 0 is an ordered pair. What if x is 1? Well, 1 squared is 1. So 1, 1 is an ordered pair. Well, how about if x is 2? 2 squared is 4. So 2, 4 is an ordered pair. Go in the negative direction. Negative 1 squared is 1. Negative 2 squared is 4. So you get this kind of U shape going on here. Now, looking at this picture, let's talk about the concept of domain and range. Domain literally just means all the x values that a particular function can achieve. The range is simply all the y values that a function can achieve. So in this case, we have a nice continuous function there. And if you think about the domain, you're thinking left to right. Where does this go that direction? Where does it go in that direction? Well, this is just going to keep going on and on and on in that direction, on and on and on in this direction. So every x value on the entire x-axis would correspond eventually to some point on this graph. So in this case, the domain would be negative infinity to infinity, every possible x value. On the other hand, the y values is the range. Where does this go in the y direction? Well, notice it starts at 0 and goes up. It never goes below the x-axis. So in this case, the range would be everything from 0 to positive infinity. There would be no negative in the range of this function. Now, you can analyze this on any kind of function. This is just a nice, easy one to start with, but the book will show you some others. Now, let's talk about the concept of a function. Simply put, something that's a two-variable equation is called a function if each x matches exactly one y. In other words, you should never have the same y value repeated. So if you have, the same x value repeated. So notice that if x is 1, that only corresponds to this y value right here. If x is 2, that only corresponds to this y value right here. So you don't have the same x matching two different points on the graph. Again, as long as the x value is never repeated, you have a function. Now, the quick and easy way from a graphing standpoint to tell whether you have a function is something called the vertical line test. And it basically says that if you take a vertical line, imagine the marker being a vertical line, and you pass it over the entire graph, if it never intersects that graph in more than one spot at any given time, then you have a function. So this is certainly a function. Y equals x squared is a function. Now, something that's not would be, for example, a circle. A circle miserably fails the vertical line test, because if you think of a vertical line, well, that intersects the graph in two spots. So here's the same x value corresponding to two different y values, and you can't have that. So circles or anything that fails a vertical line test is not a function. Now, we have some notation. Once we establish that an equation is a function, we're going to simply replace y with f of x. And that's not f times x, That's saying y is a function of x. So that just tells the reader that this particular graph is definitely a function. So this f of x literally just replaces y wherever you would have normally used y. So instead of having an xy ordered pair, you can call it an xf of x ordered pair. Instead of having an x-axis and a y-axis, you can call it x and f of x, because you know in this case you're dealing with a function. And we'll look at more of these later. Like